In this example, probability function is given p of x, random variable x values are 0 to 7 and the corresponding probability values are given 0 to 7k square plus k. First question is to determine this unknown value k. So in order to calculate the unknown value k, we use the first property, that is the sum of the probabilities in any probability function is always unity, is always equals to 1. So when you add these probability values 0 to 7k square plus k, they should be equals to 1. So by making use of that property, add all those probability values, that is the second row values in this table, probability values, and balance it to 1. Once you do this, and simplification give you 7k square plus k square plus 2k square, 10k square, and 9k, RHS is 1. And when you convert this into quadratic equation, 10k square plus 9k minus 1 is equals to 0. Now we have to solve this quadratic equation. You can solve this quadratic equation by using scientific calculator or by using quadratic equation formula, that is minus b plus or minus square root of b square minus 4ac by 2a. Or use calculator and we'll get the roots. We'll get roots as minus 1 and 1 by 10. Because when you have a k value as a minus 1, when you substitute the k value as a minus 1 in this table, probability values will become a negative numbers. 1 or 2 numbers becomes negative. This becomes a negative, this becomes minus 2, this becomes minus 3. But probability values and negative values are not allowed. That's why k is equals to minus 1 is not considered. Only k is equals to 1 by 10 is considered. Once you take k is equals to 1 by 10 and substitute into the given table, wherever there is k, replace 1 by 10 or 0.1. 1 by 10 when you replace, it becomes 0.1. This becomes 0.2, 0.2, 0.3, and this is 1 by 10 whole square, 1 by 100, that is 0.01, and so on. So when you replace k value, we'll get this is the required probability distribution function. Now the first question is finding probability that x value is less than 6, strictly less than 6. That means x values from 0 to 5 will be included, not 6, 0 to 5, and the corresponding probability values will be added together. So from this table you already know the probability value, so add 0 to 1 by 100. Don't include 6 because it is strictly less than 6. So we have to add these values 0, 1 by 10, 1 by 5 up to 1 by 100. When you add and simplify, you will get probability x less than 6, that is x is equals to 0, 1, 2, 3, 4 and 5. 81 by 100, and simplification it is 0.81. Next question is probability that x greater than or equals to 6. Look at the table. We have x values up to 7. So when I say x greater than or equals to 6, obviously you get only two values, 6 and 7, because we have maximum x value is 7. X greater than or equals to 6 means only 6 and 7. These two probability values we have to add. So we already know k value. By using that k value, this is the distribution function. X greater than or equals to 6 means this value and this value will be added, so that you will get x greater than or equals to 6 probability, which is 1 by 50, x is equals to 6, 17 by 100, x is equals to 7, 0.19. Next and last one, construction of the distribution function. Usually distribution function is indicated with a fx or f of x. This is a cumulative distribution form, cumulative probability values are solved. For example, for x less than 0, you are going to get the value as 0. For the next one, add these two values, that is p of x 0 and 0.1. 0 plus 0.1 is 0.1. For this case, you add the probability values up to this x is equals to 2, that is 0 plus 0.1 plus 0.2, get 0.3. For x equals to 3, you have to add all the probability values up to this x is equals to 3. So 0.2, 0.2, 0.1, you get a 0.5. Similarly next 0.8. Similarly next 0.81. Similarly, next 0.83. Similarly, the next value when I add it, 0.83 plus 0.17, which is 1.0. This is the way how we are going to calculate a probability distribution function. This actually I have written, this is p of x is probability function, and this f of x is a distribution function. For reference, I have taken probability function. It need not be written again, just for reference for calculating the totals I have considered that also.